And do you have any questions or anything? Mostly it's just like plugging stuff into equations, right?
It seemed pretty straightforward,
Mm-hmm.
so I think I'm okay. How about you? I'm like trying to memorize like what
Mm-hmm.
do you call the P with the little symbol above it? What's it called?
P hat, I think.
It's called what?
P hat, like an
Oh,
accessory.
yeah. Okay.
Mm-hmm. Mm, this is weird. I'm gonna send one more invite to her,
Okay.
you, just because I have you guys in a group, so it always goes to both of you. Sorry if that's
Yeah,
annoying.
that's okay.
Um, well, hopefully that works. And okay, the question I did the the preparation assignment.
Mhm.
What more it is now? And there was a few numbers that I didn't know how they got them.
Okay.
So on part 2A,
Let me pull that up.
on the first lesson, so 16.
On 16. Okay. Um, no, section 2, part A.
So it's
Well,
9A.
9A. Okay.
Um, so I know the mean, but then how
Mhm.
do you do the standard deviation again? Do we have to calculate
Um.
that, or is that just like,
Yeah. Yeah. You have to calculate it.
and you do
So
that by, is that
what?
how, do you do that by doing like 60 divided by 700 and, no, that's the other one. I don't know
Let
how
me
to do it.
pull that up. So for standard deviation, let me find it.
Oh, it looks like, okay, so it's the square root of p times 1 minus p divided by n,
Yes. Yep. There it is.
right?
Yeah.
Okay. Because it looked like they had just added it to 7%, but I was like,
Right.
how is it 90, like 0.0093 instead of just 0.93?
Yeah. They're so close that it makes it confusing.
Okay, that is good to know. Let me see.
Hey.
Hi.
Um.
Okay, we haven't started yet.
Okay.
We're just going over questions that we had about lesson 16, like the prep assignment.
It was weird. I
It was
had my roommate
weird.
help me with all of it. Yeah. I just had her kind of help me with like the homework portion, and so I kind of understand. But
That's good.
Okay. Bye. All right.
Sorry, I'm
Looks
eating.
like my battery's low, so I have to run downstairs and get my phone charger.
Okay,
Bye.
Alyssa, how are you doing
good.
after having a baby?
Good. I'm starting to feel better every day, but today's kind of like a groggy, sick feeling day, but
Mhm.
that's okay.
Did it hurt as much as you thought it would?
Yeah, more for sure. Definitely more because I had an epidural, so I was expecting it to not be very bad,
Mhm.
but it was really bad.
Did you have very much time to let it like work, or did you kind of get it and then?
Yeah, I had it for like 10 hours before he
Dang.
came. A long, long labor.
How long was it?
I started like right after our meeting, so like right at 10, and I
Mhm.
didn't have it until 7:30 p.m. the next day.
Dang.
So
Oh
Almost
wow.
24 hours.
Yeah.
Damn. What's his name?
Zay. It's short for Isaiah.
Hmm.
You can see him if you want. Levi, we bring him over here. Keeps it nice. So he's a little angry at us. Say hi to your friends. Oh. He's super tiny.
He's cute. He's so
You
little.
can't really tell, but he's
Oh, so cute.
he's fun.
That's so cool though. That was like in your body a few days ago. Now it's not.
I know. I don't really believe it. It's kind of
Yeah.
hard.
That's cool. Well,
Okay.
did you get your charger? Are you good to go?
Right, oh, yeah, sorry. Yeah, I have my charger now. Yep, good.
Okay.
Wait. Let's begin.
All right.
So,
So
And Shaylee, I was
you want me to read the first one?
huh?
Number 3.
Sorry.
I'll read the first one. So it says, in a pie chart,
And Shaylee,
why are the slices,
Oh.
the sectors, different sizes?
sorry, can you hear me, Angela?
Yeah, can you hear me?
Okay, yeah. I was just going to tell Shaylee that I was hoping to be done faster with this lesson. Because I told you, but she came in later, so.
Yeah.
If we can be
Yeah.
done, like, max by 8, that would be great.
Yeah. We can share that. If there's like really long problems and we just like know how to do it, we could maybe do it on our own.
Yeah.
Does that make sense? Okay.
Okay. Sorry, I interrupted you.
No, that's fine. Okay, so number 3. So why are the slices different sizes in a pie chart? I'm going to say it's because of the second one. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category.
Yeah, that's right.
Okay.
I'll read.
You go
Four says, how are bar charts in Pareto, I don't know how to say that, charts related? They are identical. Pareto charts are constructed from tossing a coin several times. The only difference between a bar chart and a Pareto chart is that the bars in a Pareto chart are ordered largest to smallest, going from left to right.
So I'd
I think
say
it's the
This is the
last
last
one.
one.
Yeah.
Okay.
Okay. We can conclude that p hat is normally distributed if NP is greater than 10, and N1 minus P is greater than 10. And yeah, that's true.
Mm-hmm.
So the first one.
So P is the true proportion, right? Not the sample proportion?
Yeah.
Yeah.
P hat, the sample proportion?
Maybe P is the sample proportion and P hat is true proportion.
I think p hat is the true proportion, but I could be wrong. So then that means 5 is the sample proportion.
So it says the sample proportion is P hat. Is that what we talked? Is that what we said?
Yeah. Or that's not what we said, but yeah, we will put.
Okay, so then just the P without the hat is the true proportion, I believe.
Yeah.
So
it's
is the true proportion?
I believe so. I just saw P hat, so I'm assuming that that's what it means.
Okay.
So true proportion. So the first one.
Yep.
Okay. What is N?
That's our sample.
Sample.
Perfect.
Ooh, 7.
If P equals 1/4, what is the smallest N that satisfies the requirement?
I think what we have to do is you do 10 divided by, it would be 0.25 because it would be 1/2 or 1/4.
Mm-hmm.
I'm pretty sure that's how you do it.
So you were saying 10 divided by 0.25?
Yeah, which would be 40. So the smallest we could have it be would be 40. I could be way wrong on that, by the way, but that's what I would do.
Okay. Why did you do that? What's
So-
the equation for?
The equation is NP is greater than 10. So what I did is for n, I put in n. So we're trying to find the proportion. So I put in n, and then we want to get 10. So I just divided 10 by 0.25, which is 1/4, in order to get. So I just basically brought n over to the other side of the greater than sign, and then so p would equal 40. Or you might, yeah. I'm pretty sure you.
I got the same answer, but the way I looked at it was n times p has to be at least 10. So I put equals 10, and then I plugged in p 0.25, and so 0.25 goes into 10 40 times.
Oh, okay.
Okay.
Yeah, that works too.
You did 10 divided by 0.25, right?
Yeah. That's
Awesome.
what I did.
Okay, sweet. We can go to the next one.
Okay.
So it says use the following information to answer questions 8 and 9. Suppose n is 24 and p is 0.4. What is the mean of p hat?
Are we finding p hat? Is that what we're trying to do?
Yeah.
I think it would be 0.4 divided by 24.
Do you find the mean by doing x divided by n?
You know what I found out is that the mean is just the p, so it's just 0.4.
Oh, really?
Yeah. I didn't know that before, but that's what it is. Like if you were to go, I mean, you could go through and actually like calculate it, but it'll end up being 0.4.
Okay.
I'm pretty positive of that, at least, for what I just did with my roommate.
Okay.
So like they try to make it harder than it is.
Mm-hmm. They trick us a lot. Like you just gave us the mean, but you want us to make sure we know what the mean is.
Yeah.
So then standard deviation is. Go ahead.
So what's the difference between the p hat and p then?
So p hat is, all I know is I know the equation. Oh, okay. Coming together. So we have the probability. So let's say we want to find out, we have a total population of 400, and we want to find 200 of those people. We want to sample 200 of those people. So now we have a sample. So that's kind of like the probability within that. So then p hat is finding the probability of the people who qualified for a test in the sample size. Does that make sense? So probability is over like a broader spectrum. Probability would be over the entire 200 people, whereas p hat would be over. Let's say 40 people qualify out of those 20 people. P hat would be with the 40 people.
So when we're calculating the standard deviation, then p hat and p are going to be 0.4? Both of them will be 0.4?
No. P hat is x divided by n.
Oh.
So it's kind of like, remember the standard deviation? When we had to find like the standard deviation, it tells us
that is the mean. Okay. Yeah, so p is the mean.
Okay.
I just re-asked the question. To find, yeah. I think I did it right. To just find, huh? What were you gonna say?
I wasn't saying anything.
Okay. I think Alyssa's breaking up a little bit.
I was. My computer froze for a second.
Okay.
Did you
Um,
help you, Angela, or do you need more?
Well, I was just wondering, like I have the equation for the standard deviation, but if you're doing p hat minus p, does that just mean it's going to be 0?
well, no, because p hat is, so the way that you find p hat is you put mean, which would be 0.4 over divided by 24. So p hat would be
Okay.
0.017.
Okay. Perfect.
Sorry, now I understand what you're asking.
So that makes sense now. Okay.
So standard deviation. This would be, so to find the standard deviation, we would just do 0.4.
Can you guys hear me?
Yeah, I
No.
can hear you.
Okay. My video's not working for some reason. Sorry.
Okay.
Oh, that was so cute. Okay, so standard deviation would be 0.4 times 1 minus 0.4. And then that would be divided by 24. And then we square root that.
Holy cow.
Is that right? Did I do that right?
Yeah, I think from what
I
I
got
heard,
0.00417.
you took the square root of it, right?
Yeah.
Alright. I just got the wrong answer. I know that.
What was N?
N was
N is
24.
24.
And I could have very well gotten the wrong answer. So
Oh my goodness.
So I got 0.31623.
that's probably not correct.
Did either of you get that?
You divide, so you do the 0.4 divided by 1 minus 0.4, and then, or sorry, times 1 minus 0.4, and then you do that divided by 24, right?
Right. All
Okay.
square root
And
of
it's
it.
square rooted. Okay.
Let's try it
I
again.
probably just did my math wrong.
Oh no, I got 0.1. I did it wrong because I took the square root of 0.1 or 0.01, and it's 0.1. But then I took the square root of 0.1 again.
Okay. Well, because I did this. Oh, okay, wait. So it is 0.1? I did it too. I square rooted it twice.
Yeah.
The square root of 0.1 is just 0.1?
The square root of 0.01, yeah, is 0.1.
Okay. Okay. So that was your
confusing.
answer?
Yeah.
Okay.
Okay.
So I can read this one.
Okay.
Use the following information to answer questions 10 through 13. Brittany's batting average is .300. We want to determine the probability that she would get more than 35 hits in her next 100 bats. What is p hat? So that would be 0.3 divided by 100.
Let's see.
Okay.
You're probably right. I'm just gonna double check. So what is X? X is the number of individuals. With a circle.
0.00.
N is the number of individuals.
It's 35 divided by 100, right?
It's so you do the so x would actually be p, so it'd be 0.3
I thought
divided
X was
by 100.
I thought X was the number of like certain characteristics of the sample.
Hmm.
You know what I mean?
I think it would be 0.35 because I think it's been 35 divided by 100, but I'm not sure.
I think so as well. Because X is, I think X is 35 because it's like, I don't know how to explain it.
Yeah. Okay. That's fine.
Hold on 1 second.
P is the mean, right?
Are you sure?
I'm not sure what the mean is. I thought the mean was what p is. So now I'm confused.
Right.
Alright.
And I thought the mean is what we put in for x.
Oh,
But I
see.
think you're right. I think you guys are right.
So the X is mean for another thing, but not for proportions. So you're, I see what you're thinking. Okay, so then we can do the standard deviation again. Which is 1 minus.
Maybe upstairs. There's less going on. Yeah. That could be true too. Alright, sorry guys. Alright, my friend's baby was crying, so I had to go get him. Okay, buddy. Okay, what did we decide for the mean? Did we decide did we decide 0.35 or 0.003 for that last one?
0.35.
Okay,
Yeah.
perfect.
So I got the square root. Did you get it yet?
I did as well, yeah.
Did you get 0.048?
0.046.
Well, you round it. So I got 0.048.
Really?
That's weird.
Let me try it again.
Well, I got 0.08. I got 0.0476. So I rounded to point.
Mine was 0.0458.
Oh, how weird.
Let me try it one more time. So it's 1 minus 0.3 times 0.3, right?
0.35.
Oh, 0.35.
Yeah.
I thought it was just
Oh,
P.
wait. Oh my, this is so confusing. Okay, yeah, sorry, I was doing the wrong thing. Yeah, I did. Wait.
So is it just P? It's not P hat, right? I
Well,
don't know.
that's what makes me worried about.
No, it's P hat. You're right, it's P hat.
Yeah.
Wait, I might be lying.
Well, it says, what is the standard deviation of p hat?
Wait.
So, yeah, so I just did p hat, but I could be wrong.
Okay, I'm just going back to the answer sheet. 1 second.
Good news is, though, is that we're almost done with this one.
No, it's not P. It's not P hat, it's just P.
Yeah. So root.
5, it's just 0.3.
411. How come
Yeah.
it says what is the standard deviation of p hat then?
So it's P hat. So the equation that you use is going to be P hat equals P, or square root of P times 1 minus P.
So you got 0.046.
Uh-huh.
Okay. And then luckily the z-score is pretty easy.
Oh, careful, Leo.
How do you do the z-score again?
It's p hat minus p. So it would be 0.35 minus 0.3, and then you would divide it by 0.046. So it would be
So I got
negative
0.45. So
412.
0.40.
Are you on 11 or
Oh,
12?
the z-score?
Yeah. So for number 11, we got 0.046.
Yeah, that's what I just calculated for it. Okay.
Okay, perfect.
So now we're doing z-score.
Yeah, so the z-score is really easy. You just do p hat minus p, so that would be 0.35, or no, sorry. Yeah, that's right. 0.35 minus 0.3, and then you divide it by 0.046, which is what we just got. For the
Okay. So what was the answer for that one?
I got minus, well, maybe mine's wrong, actually, because I got a big number. So let me make sure I got this right.
I got 1.087 for mine.
Yeah. Yeah, I just did mine wrong, so yeah, that's right. 1.087.
Okay.
Yeah.
So then we're looking for the probability that she'll get more. So we put our number in the
So if we just put
probability.
that output, we can find it, right?
Yeah, so I can just find that number if you don't have the applet up right away, because I have it here.
Okay.
So when you shade, because we're looking for greater than, we just shade that last one all the way to the right, and it's 0.1385.
0.1385?
Mm-hmm, 0.1385.
So we put 0.139 then?
Yeah.
Oh, 3 decimals, we're good.
0.139.
Yeah.
I'll read 14. It says, if the true proportion of people who support a political candidate is p equals 0.52, and if n equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation of p hat?
So P is 0.052, or 0.52, sorry.
Mm-hmm.
So we would just use that for the.
Alright. You want to go in your bed?
Okay, I have a number when you guys are ready.
Let me put Leo in his bed. There you go.
Give me 1 second, I'm almost there.
Okay. You can climb out of your crib?
Okay.
Let's do it. Okay. Okay.
Hey. I'm in the middle of a group meeting really quick, but I'll be done soon. Can I call you in like 30 minutes? Okay. Alright, bye. Sorry, my mom called me.
That's okay.
Okay, so I got 0.01117.
Me too.
So 0.011.
Okay, and then, sorry, tell me how to do the z-score again. It's...
So it would be, okay. So we have to figure out what p hat is. So, because it's p hat minus p. So maybe it would be, yeah, it's 0.011.
Mhm.
That sounds wrong.
Because what was the
P hat
equation
is
using?
P hat is x over n, so it would be 0.52 divided by 2,000. So it would be 0.00026. So what we would
Okay.
do is you do 0.00026 minus minus 0.52, and then you would just divide that by 0.011. So it would be, that's way wrong. Hang on, that was way wrong.
We do that same equation for 12? I thought it was easier than that.
Yeah. Well, we have to figure out what p hat is. So p hat is x divided by n. Let me.
So x divided by n would be.
Because normally that would be 0.52 divided by 2,000. But that's kind of like.
Yeah.
No. Because p is not x. But what would x be? Would we do just half of 1,000 or 2,000?
The probability that result will should just. Maybe. But that would just be 1,000 divided by 2,000, which would be 0.5. So 0.5.
So it looks like z is just the value minus the mean divided by standard deviation.
So I got an answer that seems more normal.
So the value. Okay, go ahead.
I got negative 1.818. If you were to use 1,000 for x, it would be 1,000 divided by 2,000, which would be 0.5, and then you just divide 0.5 by 0.011, which would be negative 1.818.
Okay.
Does everyone feel okay about that? Like, I don't know if that's necessarily like.
So you did 0.5, which is the value, minus, which is 0.52, and then divided that by
0.011.
0.1. And then you don't have the square root or anything, right?
Huh?
You don't have the square root or anything?
No.
Yeah, I got the same thing, negative 1.818.
So now I'm going to put that into the probability output.
Okay.
So it's just 1.818. And so we're trying to figure out like people who are losing, right?
Yeah.
So would it be the middle and the middle and the left, or would it just be the left?
Ooh. Probably just the left.
Yeah, I think just the left.
Okay.
Because I think that's just the left because they'd have to get less than half of the votes.
So the answer to that is 0.0345. So I'm not sure how to answer 16.
How to answer 16?
Yeah. Like, I don't know the difference between the
big Z and the little z.
I don't know.
Because I don't.
This
Maybe.
kind of reminds me of like the 10, how it has to be greater than or equal to 10. So maybe
Yeah.
that's kind of what I'm talking about.
Oh, okay. I think that I'm gonna put the first one, and then I'll submit first and see what happens.
Okay.
So the final one is, what is the probability the survey results will show the candidate is losing, even though the true P is 0.52? So I'm guessing that we're figuring out the 10 thing. So,
Oh, checking to see if it will work to even test? Is that what you mean?
yeah. So for the very last one,
So,
I'm going to do 10 divided by 0.52.
2,000 times.
So that's actually correct, because I did it a little bit different, Angela, and it might be easier this way.
Okay.
I just did 10 because you're just moving the P over, so I just did 10 divided by 0.52, and I got 19.231.
Okay.
And that's giving us our sample size, right?
I'm not really sure. All I know is that
I thought that gave us like the required sample size or something.
I'm not sure. I do know though that that the 16 should be the first one.
Okay.
So I'll submit it right now and see what happens. So we got 8 wrong, and 15, and 16 is the second one,
Okay.
and we got 17 wrong.
We got 15 wrong?
Yeah, we got 15, 17, and 8 wrong.
8.
Bummer. Okay. So let's start with 8.
Yes.
What did you put for 8?
0.4.
So did
Oh.
I.
I didn't put that, so that's why I got it wrong.
Okay. I'm going to leave 8. Let's
Yeah,
go.
so that's why I got that wrong. 16, I put 1.818.
Oh, it's negative 1.818.
Oh, okay. So dumb. I made simple mistakes. And then the last one I put 19.231. So that's wrong. And so is, like, 16 I got wrong also, but it's the second one.
So 17, and so you can, it says in the very last part of 16, lesson 16, says that you can conduct probability calculations using the normal probability applet. So we find the z-score.
So we would just put 0.52 as our z-score and then do the area? Or would we put 0.52 as the area?
The area, if we're, well, you have to get the correct z-score.
Yeah, you probably use 0.0, or you probably use negative 1.818.
So I got, if you're looking for the area of just the shaded part to the left, it's 0.0345.
So just 0.035.
Okay.
That should be it. I don't know what else to do. I'm going to submit mine if you want to wait.
I'll just go ahead and submit.
So we still got the z-score wrong, but then everything else is right, so that doesn't make sense.
So weird.
That is really weird.
Maybe it was just like one off or something, I don't know.
Maybe. That's alright. Okay. Are we ready to go on to lesson 17 then?
Yeah.
Sure.
Okay.
So I studied, like I was able to study a lot for the first one, but I didn't study as much for this one, so hopefully you guys can help me just a little bit.
Sure.
Okay.
So I'll read number 3. The symbol for the true population proportion is p hat, p with the little squiggly above it, or p.
Oh wait, didn't we answer this in the last one?
Yeah, I think it's just p.
It's just p, right?
Mhm.
Yeah.
Okay.
And then for number 4, I already did it earlier because I'd opened it up earlier, and so I had put true for that one.
Okay, so let's read it. The requirements for constructing a confidence interval satisfied. So we would find is greater than equal to, or
So you just have
how
to
do we?
calculate n p times p hat, and so I put 100 times 0.10 would give me 10, so that's good. And then the other one is n, and then times 1 minus p hat. So it was 100, and then in parentheses 1 minus 0.10, and so I ended up getting 90. So we were fine.
Okay.
Which means, so this number 5 is the requirements for conducting a hypothesis test are satisfied, which would be true because 4 is true.
Yeah, I got 25 and 75 for those numbers, so it's true.
Well, yeah. How do you, okay, that must be part of the stuff that I didn't. Okay, so number 6. A study of first-degree murder trials were conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Use this information for questions 6 through 8. So
Hey, my video is not working, right?
it was, but it was, so it like keeps going in and out a little bit.
It's just showing like your picture right now.
But we can hear you.
Because I'm gonna feed my baby, and I don't want you guys to have to see anything.
Okay.
So
it's good that you can't see me.
Okay, so we find the p hat.
So I'm not.
Sorry.
No, you're fine. So to find p hat is the x over n.
Okay.
So
that would be 45 over 60, right?
Yeah. Yeah. So that would be 0.75.
0.75?
Mm-hmm.
Okay.
Create a 95% confidence interval for the true proportion of first-degree murder trials in the state. In the state, the verdict is guilty. That their verdict is okay. I'm not able to finish that sentence. That's weird.
Let me draw my note.
I'm not sure how to find out.
So the confidence interval is p hat minus the z-score, and then I have the square root of p hat 1 minus p hat over n.
Say that one more time. I'm so sorry.
Okay. So I have written down, well, actually, would it be easier to calculate the one part and then plus or minus p? Okay, so anyway, it's p hat minus the z star, and then the square root. It's basically
like the confidence interval. So like if it's 95%, it's 1.96.
Yeah.
Okay. So 0.75 times 0.95.
Well, actually, it's plus or minus. It's gonna be plus
Shaylee,
or
it
minus
looks just like
1.96.
it looks just like the margin of error that you would find from like last exams stuff.
Okay. I just don't have
So
that
basically-
equation like immediately in front of me, so that's fine.
Yeah. If you open up the lesson 17 preparation assignment answer key, it's under number 2.
Okay.
Did that help, or does that make it harder?
No, I just need to go to it real quick.
Okay.
Did you get an answer, Angela?
Almost. I'm still typing it in the calculator. Okay. Okay, I have an answer, but I think it's wrong.
Is it on one of the things?
Let me go back to the thing. Check. It is not on there. Darn it.
I'm going to try it. So it's plus or minus 0.95, right?
Let's see. We're doing
For the
what
Z,
confidence
for
interval are we
Z
finding?
squared?
95. So it's going to be 1.96 is Z.
Mm-hmm.
Oh,
It's
okay.
a 95% confidence.
Okay. Good. Okay. Let's see. So basically, once you get that, you do the normal, almost like the standard deviation problem.
Yeah.
The confidence interval, you mean?
Standard deviation, yeah, because that's what you're timesing 0.196 by.
What's the population?
Wasn't it 60?
Okay, so I got. Oh wait, hang on.
Did you guys use p cat or p in your equation?
I used P.
Okay, because I started with p and then I realized I was wrong.
Okay.
Making sure you guys didn't get mistakes.
Okay, so I got an answer that could definitely be wrong. But I got like. Oh wait, is there options?
Yeah, they're all.
Okay. Definitely didn't get one of those options.
Oh man, I didn't either.
Okay, I'm gonna try one more time.
Do we have to put anything into the equation dealing with like 45? I'm trying to find the proportion of the verdict of being guilty.
Maybe we should use 45 rather than 60?
Oh, I got one of the answers.
What answer did you get?
B, so it's the 0.640 and the 0.860.
Okay. Did you get that by using the 45?
It was by using 0.75.
No, I mean for like what did you use 60 people or 45 people?
60 people. It's like 45 out of 60, which we said was 0.75.
Okay.
So it was 0.75 times 1 minus 0.75 divided by 60, the square root of that, and then multiplied by 1.69 or minus 0.7.
Okay. I'm okay with going with that.
I was doing the wrong numbers the whole time. I was using the ones from 4 and 5, so mine's way off.
Okay.
So what did you what you did again. You did, for like
So
the
I
standard deviation, what did you do?
use the standard deviation.
Yeah, so you did like 0.75 times 1 minus 0.75 divided by, did you do 45 or 60?
60, because our full sample size is 60.
Okay, so are we supposed to do it from the whole sample size or just from the guilty?
Oh, I see what you're saying. Like that could be a trick where you do get one of the answers, but you did it wrong.
Do you want to try using 45? Are you doing it right now, Alyssa? Or no?
No. Let me try it, because I had done the other one. Try to beat him before he finishes.
Oh no, you're fine.
And what are we adding to it? It's p hat. Do we add p hat plus or minus all of that?
Yeah, so 0.75 plus or minus 1.96.
Right, okay.
Yeah, you do use 60. I'm just looking it up in the textbook reading.
Oh, cool. I do have one of the answers with 45, but if it's using 60, then that's awesome.
Well, because in the example in the book, it has like 249 over 248 minus 1.96, and then for like the divided by under the square root, it has 428, which is the number that was at the bottom of the fraction. So,
is it trying to find the confidence interval for the whole population or for just part of it?
It's finding the confidence interval for the true proportion P.
That's tricky. I think I'm going to put A, because that's what I got with 45. I got A,
Yeah.
so 0.654 and 0.876.
Oh, okay.
So I'm going to put that, and if I'm wrong, then we'll know that it's, you always divide it by the total sample.
Okay. Sounds good.
Well, okay. So I have been trying this and I haven't gotten any right answers, so that's my own thing. But I did notice it says create a 95% confidence interval for the true proportion of first-degree murder trials in the state that their verdict is guilty. So it says 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. So either we're creating a confidence interval for 45 out of 60, or we're finding a confidence interval out of 45. Does that make sense?
I did 45 out of 60, yeah.
Okay. All right. Number 8. Is everyone okay to move on?
Yeah, just one real quick. So Angela, you did 45 divided by 60 for your N in the
No, so for N I used 60, but like for the proportion for P hat with 45 divided by 60.
Number 8 answers the question you guys have.
Okay.
If you increase the sample size from 60 to 80. I think that answers it, but maybe not.
Yeah. Good. Whoa.
So the confidence interval, if you increase the sample size, would decrease, correct?
Yeah.
Yep.
Perfect.
Okay. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest N can be, and both requirements still be met?
So is that where we do 10 divided by 2?
Yeah.
Okay. So
Well, it's like, okay.
isn't it 0.5?
Sorry, yeah, it's 0.5.
So it'd be 20.
So it's 20.
Wait, so you do 10 divided by 0.5?
Yeah,
Yeah, because
P equals 1/2.
Oh, because it's not p hat, it's just p.
Yeah.
So it's
But
25?
do we need to do another test as well? The n minus, or the, yeah. What was n for that? Let's see.
For 9, was it 20 or 25? 20, right?
20.
Oh, we're figuring out n. Okay, yeah, so it's 20. Okay.
And then I think the same thing, it's the same question for number 10, and I got 100. Because
Okay.
it's 10 divided by 0.1. So I got 100.
Yep.
And then for questions 11 through 16, we use this problem. For the water quality study in the reading, about 60% of the things, water quality indicators have historically been associated with good health. Researchers suspect that water quality in the area has decreased. They conduct a hypothesis test using a significance level A equals 0.05 with the following hypothesis. So the null is P equals 0.6 and the other one is P is less than 0.6. And N equals 80 and X equals 38. Were you able to hear me?
Yeah, I heard
Yep.
you.
Okay. So the conditions for conducting the hypothesis test are satisfied.
So
We have to do n times p and n times 1 minus p to figure that out, right?
yeah.
And p
So P
is,
is 0.6.
yeah. Looks good to me.
I'm gonna say yes. I didn't actually calculate it, but it should
Yeah,
be.
it's 48. So
Okay.
Yep, 48 and 32, so we're good.
Okay. And then for the other one, it is
what is P hat?
X,
Luckily in this one they give you X.
right?
So 38 divided by 80, which is 0.475.
Wait, 0.475?
Mhm.
Oh, okay, I got that now. That's weird.
Yeah, I just did 38 divided by 80.
Wait,
And
wouldn't
then-
it be 80 times 1 minus 0.6?
No, it's just,
P hat, the equation is X divided by N.
Yeah. X
So it's just-
divided by n?
Yeah.
yeah.
So X
Oh,
is
okay.
38 and N is 80. Yeah.
Okay.
And then we have to find the z-score. So we have to find standard deviation, and then we can find the z-score.
Wait, so for 11, are we saying false then?
11.
No, 11's true.
Okay, that's why I was
11's
confused.
true.
Okay.
Yeah.
And then 12 was x divided by n,
Yeah, which is 0.475.
0.475.
Mhm.
Okay.
Okay. So
For the z-score, can we just put that in the applet?
no, we have to. So we have to find the standard deviation. and then we have to
Okay.
find the z-score from that. So it's the 0.6 times 1 minus 0.6. That's it.
Is it p hat or p? Oh, you're right, p. Sorry, I always get confused.
Yeah.
So for the standard deviation, you get 0.055.
That's what I have, yeah.
So then you do p hat minus p, so 0.475 minus 0.6, and then you divide that by the standard deviation. Do you know what the standard deviation was again?
Yeah, it was
It's
0.05.
0.055.
Right.
So for the z-score, and I could be wrong, but I got negative 2.272.
But 7.3, right? That's what I have.
Yeah, 2.273. Negative. Can't forget the negative.
That's right.
Okay. What is the
So then the
p
p-value is fine by putting that into the app.
Yeah, I'll
What?
put that in. So we have to put the negative. It's negative.
2.273.
And are we looking for the greater or less than?
I think it was less than.
I thought so too, but let's still, yeah, it's less than 0.6.
Okay, so it's 0.012.
Okay.
Yeah, that's what I have.
0.012, and then so it equals 0.012, so that means that it is,
Fail to reject, right?
yeah.
Yeah.
We reject it if it's lower than the level of significance, right?
Yeah.
Well, because so p is
Wait.
0.012, and we're looking for, so this is either p
No.
equals
You
0.6.
rejected.
Yeah, you reject it.
Right? Yeah. Because if it's high, then you fail to reject it.
Well, here's what I'm looking at really quick, and I might be wrong, but it says, if you look at that equation, it says p equals 0.6. That's what they're thinking it is. Well, we just found that the p-value is equal to 0.012. So it doesn't
Right.
equal 0.6, and it's less than 0.6. So we would reject the null.
Yeah.
Yeah, so we reject it, right?
Okay.
Lower than the level of significance, which is 0.05.
And then the last one, which of the following best summarizes the conclusion of this test? So there is insufficient evidence to conclude that the water quality in this area is decreased. I think.
I thought it would be A, but I think I got almost all of these wrong on the test, so.
Oh my goodness, how did you guys do on the test?
Very bad. But I mean,
I
I do really bad on
felt like
all of
I
them.
answered everything all right, and then I got my score, and I was like, oh.
Yeah,
Yeah.
I got like a 50 on it. So
hard.
so I did not do well. But that's okay.
I took longer to turn mine in since I went into labor, so
Yeah.
I got a 75 though.
That's
Bummed.
good.
I got a 72, I think.
Yeah.
But
It
yeah.
was hard. It was like
Hard, yeah.
it was
and
less math.
I worked through everything. I was like, okay, this is going to be okay. And then I was like, what?
So
Yeah.
they're trying to let's see, what are they trying to figure out in this? They
So that
conduct a
last one,
hypothesis test.
I think it's A.
So for the water quality study in the reading, about 60% of the microvertebrate water quality indicators have historically been associated with good health. So the researchers suspect the water quality in the area has decreased.
so
There is
I have a like a weird way to remember when to do sufficient or insufficient.
Okay.
So on 15, if we reject the null, for some reason so instead of failing to reject, which to me sounds negative, rejecting the null sounds positive. So I know that it's sufficient and not insufficient because that's a positive word. And then you just have to find out what the alternative hypothesis is.
And then plug that in.
Yeah, and so then the alternative, there it is, hypothesis, is that trying to find out if it's decreased. So then A would be sufficient because we rejected, and it has decreased because that's the alternative.
Okay.
Right.
So it's kind of cheating because I don't really understand what it all means, but I know how to link them together.
I mean, that gets you the answer you need.
Does someone want to submit?
You want me to submit? Okay, go ahead.
I did it, and we missed 7. I missed 7. Did you guys put B?
I still had B, but I was waiting to see how we did.
Yep, so it's B, so we would just do divided by 60. And 14, okay. That's all though.
14. Oh, that was our p-value.
Which was the shaded area, right?
Yeah, let me...
Did you guys, wait, what'd you put, 0.012?
Oh, it's, because what it is 0.0115. So it would have been rounded 0.012.
Should we try putting 115 and see what happens?
Or just 1, 1? I don't know.
Oh, yeah. Oh, yeah.
I still got it wrong, so...
That's so weird that we're getting z-scores right or wrong and that the p-value is right or wrong, you know?
Yeah.
Okay, so 15 is... Oh, no, 14 was 0.011.
She got it wrong.
I put I put 0.015.
Oh. You can get credit for that. I would email him.
Okay, I think that's it, right? Oh, I haven't watched the group meeting, or is the group meeting tonight? I think it's tonight. I don't know. But the group project, I haven't looked into that at all yet. Have you guys?
Yeah. No.
I have a little bit, so...
We have to come up with something to test.
So... Okay. I could do
the
first part.
So we need to, work on together and turn something in by Saturday, right?
Yeah, what it is us just assigning different steps to people. So, I could just assign those to you guys. I'll just do every other kind of thing. Is that okay?
Yeah, sure. That's fine.
I'll just go me, then, or maybe I won't start with me because I'm doing this one. So I'll start with Angela, then Shaylee, then me, then Angela, then Shaylee, then me. So that just goes through 7 steps of who's in charge of what. And as soon as I do all of that, I will email it to you guys. So if you'll give me your emails before we go.
Sure. Okay.
So, Angela, what's...
My email is angela.m.bailey@gmail.com.
Bailey, B-A-I-L-E-Y, right?
Yeah.
Email?
Gmail, yep.
Okay, and you said M as in milk,
as
right?
As in Michelle, yeah, M, yeah.
Okay. And Shaylee, yours is pretty easy too, right, Shaylee?
It's normally easy, but can I give you my school email?
Yeah, totally.
Because I never check my Gmail ever.
Yeah.
Except for this. It's just FLE. 1, 2, 0, 1, 6,
BYU.
mm-hmm.
Hey, sweet. I will email that to you guys just sometime before Saturday.
Okay,
Awesome.
thank you.
Thanks.
Unless I have questions on it, then I'll
Then we'll hear from you soon.
figure out what we would want to do, because I think we have to come up with the sample test that we want, like a research question.
Oh, okay.
It feels nice
All right,
that we're
yeah,
done
I'll
with
take a
this.
look at that in the next day or two and yeah, read through it and see what I
Yeah, that'd be great. Just as long as you guys can do it before Saturday.
Yeah.
Yeah.
Okay, well, I'll go post our lesson then.
Okay, thank
Awesome.
you.
Okay, have fun in Hawaii.
Thanks.
Yeah. Bye.
Bye.
Kaylee, have fun in Rexburg. Oh, she left.